Well, hello, everyone, and welcome to the June 2024 edition of the St. Louis Java Users Group. Next slide. For those who don't know, the St. Louis Java Users Group is an informal group, but we've been around for quite a while. Our first meeting was in May of 1997. Attendance is free. There is no formal membership list or anything like that. When we meet, it's normally on the second Thursday of each month, except December, when there is no meeting. There's just too many things happening over the holidays for us to be able to organize a meeting in December. So for those of us who are here in person, you can join us for food and social at 6 p.m. in the training room. And we try to get the meeting started at 6:30 p.m. It's, assuming all the technical gods cooperate with us and everything. What's that?
I'm going to change my screen share.
We need to start over?
No. We just didn't show the slides to everybody.
Yeah,
Oh.
just saying the first slide.
Okay.
All right, I'm going to stop recording. Well, that way we can go on it.
We'll trim the audio. We'll trim the thing before it gets uploaded to YouTube.
Now we're going to
Okay.
Inside matches the outside.
Inside matches outside. Okay, so I can continue on? So for those who don't know, the St. Louis Java Users Group is an informal group. We've been around for quite a while. Our first meeting was May of 1997. Attendance is free. There's no formal membership list or anything like that. We normally meet on the second Thursday of each month, except December when there is no meeting. We're not able to organize anything in December because of the holidays. For those of us in the training room, you can join us for food and social at 6 p.m. And we try to get the meeting started at 6:30 p.m. as best we can. And for those of us who are online, the place that we're meeting where this video is originating is the Object Computing Incorporated training room. We're at 12,140 Woodcrest Executive Drive, Suite 310, and that's in St. Louis, Missouri. Next slide. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So with the picture from left to right, we have Ted Doyle, Bruce Alspaw, that's me, Robert Levitt, and Wei-Chi Gao. And then on the right, we have our newest Java Users Group Steering Committee member, that's Zach Klein. You can reach all of us at the St. Louis Java Users Group Steering Committee if you were to send an email to that address that's on the bottom of your screen. That's javasigsc@ociweb.com. Next slide. The St. Louis Java Users Group would not be possible without the support of our sponsors. So from left to right, top to bottom, Object Computing Incorporated. They are our lead sponsor. They have been with us since 1997, filling in with food and everything. That's what originally got us started. JFrog is also an important sponsor as well. They sponsor the Zoom subscription for you folks who are watching online, covering that cost for us. And so they've been great. Now, at the end of this meeting, we will be raffling, after the presentation, 2 JetBrains licenses for any JetBrains product of your choice and 2 Manning ebooks of your choice. Now, the thing is, you do have to be present to win, either in person or online. So for those of you who are watching the YouTube video, when we eventually get that uploaded, sorry, you're too late. You do have to be present either online or virtually to participate in the raffle after the presentation. Next meeting. So tonight we have a special sponsor here today, and that's our food sponsor here. Nick from Enterprise Mobility is here, and he sponsored the pizza for us. So I'd like to hand the speaker over to him, the microphone over to him. Could you introduce yourself and tell us about your company and the positions that you're hiring for?
Absolutely.
There you go.
Thank you, Bruce. Good afternoon, everybody. Thank you for having me. My name is Nick Chapman. I work in talent acquisition at Enterprise Mobility. For those of you here in person, please feel free to get some more pizza. Sorry. Oh, I think the camera's pointing right here, actually. But, so yeah, those of you in person, get some more pizza. There's lots left. Those of you virtual, you'll have to come back next time, get some. But again, thank you for having me. I work in talent acquisition. Most people know Enterprise Mobility for our rental car platform. Enterprise Rent-A-Car, National, and Alamo. It's hard not to know of one of those brands. We actually just rebranded from Enterprise Holdings to Enterprise Mobility within the last year. So you may have seen that, especially if you're local to St. Louis. Really, the thoughts behind that are just trying to draw more attention to some of those other business avenues that we have. So in addition to the rental car platform, we have things like our fleet management division. We have things like our car sales and commute and car share division. Some of those you can think of like an hourly subscription model. They're very popular at some of our universities where you can use a car when you need it, check it back into the university, things like that. The fleet management division, Domino's is one of our biggest competitors. Maybe I should have brought, or not competitors, biggest customers there. Maybe I should have brought Domino's instead of Cecil Whitaker's, but we manage their entire fleet of vehicles so that they don't have to worry about that. They can just focus on making pizza. So not to get too long-winded there, I just like to share some of those other avenues about enterprise because I think the rental car side is what most people know us for. On the IT side, we recruit across the board. We also do a lot of remote recruiting. So those of you online that aren't in the St. Louis area, we have a lot of virtual hiring. So check out our website. I've got my information up here. Feel free to take a picture of that. I'd love to be a resource for you however I can. Most of our positions are going to be Java-based on the software side in some capacity. From there, it kind of depends. Every team has their own flavor. Some front-end teams are working with React. We've got some back-end teams that are all services-driven. There's not even a GUI to interact with, so it can vary quite a bit. But again, would love to connect with you. I don't want to take up any more time. Thank you for having me, and enjoy your evening.
Yes.
Well, thank you for sponsoring the food. And I see you have your email address up there. It's Nick, is there a dot in there? Nick.Chapman@em.com. Enterprise, I just EM for Enterprise Mobility. Okay, easy to remember. Thank you very much. Okay, next slide. All right, so other announcements. Manning is one of our sponsors here. So if you would like 40% off of any of their products, when you go through their online checkout system, you can use the Jug discount code. That's Jug13 there. Our sister Jug is in Kansas City, Missouri, and they will be sponsoring KCDC Developer Conference here towards the end of the month. I mean, it's coming up. It's just right around the corner here, June 26th.
My slides are already done.
Your slides are done. You're presenting at it, Sean.
I'm also an organizer of the KCC.
Well, good.
We're right down the street.
Well, that's great. Yes, and I'm glad you can make it. So if you want more information about that conference that's coming up, that's www.kcdc.info for all the details. All right, next slide. Now, Venkat, by the way, who will be here next month, has a convention of his own, and that will be September 30th through October 2nd. And there's a $50 Jug discount code, and the website to go to for that is www.dev2next.com, and there's a little barcode there that'll take you to more info about how to get the discount code for that, but it's STL-Jug. Okay, next slide. All right, so next month, Venkat's going to be here, hopefully, with asynchronous programming in Java using virtual threads. And I mentioned this earlier, but per his request, this is going to be an in-person meeting only. And sorry, there will not be a YouTube recording. That's kind of the way he wanted it. In September, we have Ivar Grimstead from the Eclipse Foundation. And he's going to be flying all the way across the Atlantic to be here and attend some other jugs too. We're on his tour, and he'll be talking about increased performance and developer productivity with Jakarta EE11. Next slide. So if you want to keep up with our presentation schedule, that's easy to do. Just go to our meetup site. That's meetup.com/gatewayjug. As we schedule presentations, they will be posted there on our meetup site. Now, our past presentations are uploaded to our YouTube channel. It's actually my personal one, youtube.com and it's @ my name, Bruce Allspaw there, if you want to watch those. So if you are interested in giving a presentation or would like to become a Chug sponsor, again, you can email the steering committee at that address there. That's javasigsc@ociweb.com. And right now, we're looking for a speaker for August, October, and November. Those meeting spots are open. So I'm trying to reach out to people, but if someone has a speaker in mind, talk to us. All right, so that's probably enough for me. Why don't we get to the next slide? That's the last one? Then we're all done. I'm gonna hand it over to you.
Well, and I'm going to hand it over to my kids. My
Okay.
kids have a very important
Announcement to make, so I'm gonna let them come on up.
Hi, my name is Sean. I'm a Springfield grad kid. I live right down the road in Kansas City. I think if my lights on, let's make sure.
I'm live, and Logan, you are live. I'm gonna let you drive that, and we're gonna get you going, because this is kind of the thing. My son has traveled with me. This is the first time that my other two, Lola and Lainey, are gonna be presenting. So here, I'm gonna hand it off to you. You got it. I'm gonna be looking, and I'll just make sure that you're on track. Can everybody see the screen? Oh, maybe that might be a little bit hard to see.
Little
Let's see
bit.
if we can change it up. We're gonna cancel this, and we're gonna change it. We're gonna put a new window here for you. You want me to press the button?
No? Okay, then you can
Okay.
say your lines.
Sean. That's my name. I put all my stuff in fun stuff. And we're gonna bump that up a little bit so that hopefully everybody can see. Oh, it's up a little bit at the top, but I think we'll be okay. I think.
Yeah, we'll be okay.
Are you ready?
Yep.
So we got a little pre-work there, and I'm gonna leave it up to you.
Alrighty
All right,
then.
can you see?
Yeah, I can see. Alrighty. So we are going to be using Java 8. Do not do this at home. It is very old. Yes.
You gotta,
It's
that is older than.
ancient. And we're gonna use Spring Boot 2.6, also ancient. Let's start up the Spring Boot application. Start it up in 1.468 seconds. Let's keep it going. Let's check the application health. So far it is up and running. We are doing great. Processor is using 382.7 megabytes. That is a lot. A lot. Yeah.
Hey, I'll take
All right. Now let's stop the Spring Boot application. Man, I don't even know who would want to get it up and running.
I mean, it's Java. It'll still run.
Ancient Java.
What are you doing now?
I am going to upgrade, I think.
Yes,
Yes, that's what I'm doing.
we're upgrading using Open Rewrite. How many people have heard of Open Rewrite? Not enough. Okay, we have a lot of work to do, son.
All right. It was a success. We're doing good so far. Now we're going to switch over to Java 22 for Spring Boot 3. Just then,
That's more like it, right?
Yeah.
We don't use Java 8 in our house. I don't know what you guys do in your house. In our house, we make our bed, we brush our teeth. We do not use Java 8.
all right, let's keep it going. All right, now we're going to start it up. Is this the one that takes for? Oh, no, it's not. All right. That started up in about 1.438 seconds.
Sometimes the same, but now we're on Spring Boot 3.3,
Yeah.
which has been out for like weeks.
Yeah. Almost middle-aged. Oh, I just skipped through.
Yep,
All right.
it was healthy.
Yeah, it was up. It's a demo.
How much memory is it using now?
233.1.
That's a better number.
Way better number.
That's
All
a
right,
better number.
keep it going. Let's stop it just because, it takes up a ton of space. Let's keep it going. Now we're going to build a native image with AOT processing.
God, crushed it. So this is one of the cool new features that we got with Spring Boot 3, Spring Framework 6, native images. How many people have played with the native images using GraalVM? Wow, not enough. Let me ask this question. Who has unlimited budget I mean, that was great, raising your hand. Typically, nobody raises their hand for that. Typically, people are being asked to do more with less, right? Always. So this for me, I don't have cloud money. I have Raspberry Pi money. So this allows me to take production ready, enterprise grade Spring Boot apps and compile it to statically linked native code that I can fit on a $15 Raspberry Pi. So I can have all of the awesomeness of Spring, Java 22, and I can fit it onto my $15 Raspberry Pi. This is why I'm excited about this feature. What it's doing is looking at all of the bytecode. Starting with Java 1.3, we had hotspot, and it would say, oh, I can see where you're using this code the most, and it would optimize it down to the operating system and that architecture. Same thing here, GraalVM. Graal Labs said, hey, we're gonna do the same thing for all the bytecode. But it's a little trade-off. It took 1 minute and 6 seconds to do. Is it worth it?
It actually took 1 minute and 14. You said it wrong.
Oh, total time. And I was looking at the compile. It was 1 minute 6, but good number.
I know.
Thanks for checking me.
All right, now we're gonna start up the native image.
Got security in place. Still Spring Boot 3.3,
Yep.
which is way better than 2.6.
What
It
is
started up how fast? Super fast.
Yes, too fast.
All right, let's keep on going.
All right.
Is it healthy?
Yes.
Does it still work?
Yes.
Okay, now this is the moment of truth. Ladybug, are you ready?
You ready for this?
Logan,
It was
that number
only
say?
using 84.6.
84. Yeah, 84, that's a good number. Her line was, I can count to 84. 1, 2, 3. There it goes.
Okay. All right. We don't need to do that. All right. Let's keep going.
So much better.
Let's stop it.
We did it.
Yeah, we're doing great. All right. Now let's look through this
Give
stuff.
us a recap.
So we started with Spring Boot 2.6 with Java 8, ancient. It used 280 or 382.7 megabytes. That's huge. Spring Boot 3.3 with Java 21 only used 230.
Java 22, that's a typo. My
Oh,
fault.
okay.
Demo right before we got here.
Okay. It only used 233.1 megabytes. That's a 40% saving.
So let me pause right there. If you went to your company and you were able to save them 40% or even 20% on your Java workloads, you think you'd get a pat on the back? Maybe. No pat on the back, not for you. No, they need more. They need more than 20%. What if you were able to save them 78%? Still no pat on the back, not even a friendly worded email. Well, in my house, if you save 40% or 78%, you're getting cookies.
Yeah.
And maybe, depending on your management, you might get cookies too. Because those are kind of big numbers. You can do the math. It'll add up, right? This is great.
Yep.
Logan, thank you so much. Lola, Laney, Crush. Laney's doing her things. Thank you so much.
All right.
That's a great way to get started. Give me 5. 5. All right. And I'll take that mic. Thank you. So, no, you don't. You need Java 17. You need Java 17. So what it's doing is it's using GraalVM. Wait, where? Okay, that's cool. You want to bring the chair over? You can stay right with me here. So when we brought out Spring Boot 3 and Spring Framework 6, they had to make a decision, right? They had been supporting Java 8 as a baseline, and that makes sense. But in order to move forward with these advanced deployment strategies and to try to save money, right? The whole thing here, I said, we want to scale to 0. And when I say scale to 0, I'm usually not just talking about your apps. I'm talking about your infrastructure too. Let me do my little intro. I have a fast intro, and I don't have a whole lot of slides prepared either. What I'm going to do is I'm going to show some stuff, potentially. Who knows? Sometimes I have an intro here. I try to do everything in public. I try to make things available. I don't, I'll hide my credentials, my secrets and stuff, but most everything else, it's public. All the code, all the things. This is 907 days. In this role, I've been in for 907 days. Before that, I was a partner solution architect over at Redis. Redis, that's where I started talking about latency is the new downtime, right? Where companies were saying, hey, I have a 2 millisecond latency on my data store, and that's become a bottleneck for my business. The transactions, the number of transactions that I can do in a day is being bottlenecked by a 2 millisecond latency. And if you could get that down to a 1 millisecond latency, we could make twice as much money. So that's the kind of situations that I was working with for 411 days over there. Before that, I worked at Pivotal and VMware. I was a happy customer of both Cloud Foundry and Spring Boot, and I got excited about the whole thing because before that, I had a little startup, and my startup was awesome. First product, we did not use Cloud Foundry. Second product, we did use Cloud Foundry, and it was much faster, it was better, and we were all excited. So I fell in love with it again because I worked at Garmin. Garmin was adopting Cloud Foundry, and that's where I fell in love with Spring Boot. So this is kind of the journey. This is my background. This is what I've done, and I'm happy. I'm happy to be here. So when I say scale to zero, I'm not talking about just my Spring applications. I'm also talking about my infrastructure. So I'm going to start here. I'm going to ask you a question. If you have environments like dev, stage, test, performance, whatever they are, and you don't have any code being deployed to them, why are they up? How much infrastructure, how much money could you save if today, right now, it's after hours, nobody's doing any work, hopefully, right? We want that 40-hour week. If nobody's doing any work, why is dev even up and running? Especially if you're in the cloud. You're being billed per millisecond. And if it's serving no purpose, why is it running? Sounds like a waste of money. Sounds like somebody has an unlimited budget to me. That's right. That's right. So I'm going to start there. That's the journey that I had to deal with when I was at MedZero. We were moving from the data center into the cloud. I had to make that 3-year commit spend on somebody's data center in 2 different geographies. I had to make the cloud affordable. And that was the mark that I had to do. So I had to do all the things in the cloud, but make it on-prem 3-year commit affordable. And the only way that I could figure out to do that was to scale my non-prod environment to 0 when I wasn't using it. And that's how I did it. So I'll let that sink in for a minute because that was awesome. And I talked with a lot of startups, right, in Kansas City. I worked with a lot of startups, and that conversation, I'm going to say it here, hear me now, listen to me later, but you, maybe your friends are going to have, yeah, that's okay. You're going to have a startup idea, and your friends are going to say, hey, you know what? I think I'm going to go and stand up a bunch of cloud infrastructure to launch this startup, and they're going to build their pipelines. They're going to do all the things. Stop. Run it on your laptop first. Until you get MVP, until you get some funding, it should run on your laptop. Does that make sense? Like, why? How many times have we done that? I've seen dozens of startups fail before they even get an MVP. But they had beautiful Kubernetes architectures. They had beautiful pipelines. They had all sorts of things, but everything was running 24/7. They were doing all the things that they wish they could have done at their other job. And they were using the startup to kind of practice those things. But right now, from here forward, don't do that. Have it running on your laptop. So Spring Boot with the AOT processing and native images, that was a game changer. I said that I'm a fan of Raspberry Pis. And I spent a lot of time, not on this one, but one that was similar. Build packs, does anybody use build packs? Build packs? Oh boy, I have so much work to do. We don't know about Open Rewrite, we don't know about build packs. Build packs are a way of delivering OCI images, but they provide a little bit more consistency. And I can have upstream support. In the case of the Java build pack, there's been a lot of influence and effort and contributions from the Spring team. And the Spring team has a lot of contributors to Tomcat and OpenJDK and the like. And they brought all of the best practices into this build pack. And I have seen customers that take all of the lessons, the algorithms, and the things like the memory calculators that exist in the build pack. And they said, oh, I'm going to pull that out of the build pack and I'm going to put it into my Docker file. Again, I have a lot of these pithy one-liners since I've been in this role. Friends, don't let friends use Dockerfile. Because when a new CVE comes out, right, which they're coming out every day, you're going to go to bed tonight, tomorrow there's going to be a new CVE. Somebody found something somewhere. And what do? If that CVE was in the base operating system of the Docker file that you're running in production, then what do? What are your options? Have you ever had to deal with that? I did. I made that mistake. I know how to build Docker files. I'm going to do that. And I had Docker files for every project. They're in every repository. There was a Docker file. And when a CVE came out, guess what I had to do? I had to patch every one of those repositories. I had to patch every one of those Docker files. I had to run all my pipelines for every single one. I told you about product 1 and product 2 when I was at MedZero. Product 1, that's what I was doing. There was a new Spring release that was coming out all the time. I'm going to show you something cool. I didn't go through all of my introduction. You can find me at all the places. I'm at Deshaun. I've been around for a while. I do Spring office hours with my friend, my colleague, Dan Vega. Every Monday at noon Central, we have a show. And it's the thing I wish I had when I was in your seat, when I was doing development, when I was trying to get to production, when I was trying to keep up with the industry. I wished that somebody would give me like a TLDR of what's going on. Like, what am I supposed to be paying attention to? So that's what we do. Spring office hours. There's always the news, and we always talk about the roadmap of what's being released. If you're using Spring Batch in production, or you're using, what's up, Spring LDAP, and maybe you ran into an issue, or maybe you want it to go faster, you should be grabbing the latest version. You want to be paying attention. Spring by itself has this concept of a release train. So let me pause here. How many people are using Spring in production today? My kids, of course. Yes. All right. This idea, one of my favorite features of Spring is a release train. When I'm on Spring Boot 3.3, all of its dependencies, the other projects that are in the Spring umbrella, like some of these, like the Reactor, Spring LDAP, these projects all have kind of a pairing. Like this release train for 3.3 is going to support Spring LDAP 3.2. All of those versions. So across the projects, they are guaranteed to work together. So when I start a new project, I don't have to do a whole lot. I don't have to do the dependency dance. And before we had Maven, right? Oh, we did some awful, disgusting things with libraries and putting them into our repository. I see some nods. And then we did the live version dance. Like, oh, if I upgrade my driver, all of a sudden now my driver is not compatible with this other thing. And I spend weeks trying to figure out compatibility of the versions. That's it. I mean, we're here. The nice thing about Spring is I can go, this is start.spring.io. I can go and create a new project. And of course, I'm going to grab the GraalVM support. I always add the actuator. But in that POM, I'm going to grab, I use Maven. We can talk about that. And the latest and greatest. And I'm going to hit this button. But we can go take a look at the POM. And in that POM file, I don't have version numbers for all of those dependencies. It's getting the versions from the release train. So everything under 3.3 has its own versions, and those are defined already. So I don't have to define the versions for those dependencies. And I do get nervous when I get outside of that release train. I get nervous. I want to make sure that when I bring in that third-party library, it's not going to break everything. And lucky for us, we can go and look at the Spring project and we can see how they're testing. So we can see what should I be testing in my application once I pull in a third-party library, which is kind of nice. Nice part about being open source. The thing that we like to say is using Spring Boot, it's like pairing with somebody on the Spring team. A lot of times in my career, I thought that I was a better developer. I thought, oh, I figured it out. I got it. And I realized like, oh, I'm not better. I just had more time. Before I had kids, I could spend 20 hours a day working on that problem and being really clever to figure it out. And then I saw Spring. Spring was great. Like, man, this made things a whole lot easier. And then Spring Boot came along. And once I started really investing in Spring Boot, I saw that, wow, all of the patterns that I thought I was really slick, I thought I was clever, all of those things that I'd ever done, right, that maybe I didn't realize I'd read it in a book or I saw it on a blog somewhere, all the times where I thought I was really clever, I realized today that the Spring team's already got a pattern for that. They've got an annotation or a test case or a guide that shows exactly how to do it with 1/10 of the code. That's the power of a framework. So anytime I find myself being clever or how should I do this, now I'm asking myself, like, do I really need to be clever on this? I mean, I'm not creating a self-driving car. I'm not, flying rockets into space. A lot of times the work that I'm doing, a lot of times the work that my customers are doing is really simple. They've got great requirements. Let's get some information from a website. Let's put it into a database. Maybe let's do some analytics on that database. Oh, and my son will go with my daughter. But I don't have to be really clever for a lot of those things. For a lot of those things, it's just having good requirements, and the Spring ecosystem kind of gives me a pattern in order to take it to production. And I like that. So, yeah. Okay, you go with them. Thank you. All right. So, the native image, this allows me, this is the big thing. I started this project, I was using Raspberry Pis, and I was using build packs in order to take my Spring Boot apps to these Raspberry Pis. And it doesn't sound like a big deal, but the Raspberry Pis are a different architecture. They are ARM64. ARM64, unlike, how many people are running I see at least one Mac, the Apple Silicon, right? It's a thing, but it came a long way, right? I had a conversation earlier today that Raspberry Pis, I think, came out in 2011, 2012. Oh, wow, the Raspberry Pi 1. All right, and it was 32-bit for a long time, and then they moved into the 64-bit, right? The Raspberry Pi 3, I think, was the first 64-bit one. But just that was kind of cool. We can now take Java and run it on Raspberry Pis, cheaper hardware, and especially now, I'm working with people all over the globe. And Apple Silicon is not even available all over the globe. But a $15 Raspberry Pi or a $45 Raspberry Pi is very affordable all over the globe, right? It is hard to find more power per dollar than a Raspberry Pi or similar device. So when I'm working with people, you can imagine the areas around the globe where it is difficult to find that. I can deliver Java, and I can deliver hardware platform that they can actually use, and it's low power. I was in Europe a week and a half ago, and a friend explained that just their one server that sits in their closet I think he was in Germany, costs $200 a year to run. $200 a year just for the electricity, right? Like that's one thing we got. Like I know it doesn't cost that much to run my Raspberry Pis at home, but just this idea, there's a lot of vectors that go into what we're taking to production. I built this ARM64 build pack so that I could take my native code and I could fit it on a $15 computer. So it's Java, just like my son did, compile it to a native image and then land it on a cheap computer. This is cool. So now, just the footprint, even if I don't scale to 0, the footprint that my son showed, let's see if it's still up there. It's not. It was a 78% savings. And for some organizations of a certain size, that number at scale is millions of dollars. When I took my son to Montreal, we said, that's US or Canadian, right? It's $1 million. Like, this is what you can save if you're taking those steps. So we, as developers, if we're doing our job, trying to make our company money, if you care about your company, I'd like to keep my job. And I want to do everything I can to save my company time or money or resources or make them money. So all of these new things, it's a bunch of small adjustments that end up adding up into really big value for your company. So now I was working on this build pack and I got really interesting places, but it started off with Raspberry Pi. Then we started to see Ampere showing up in the clouds. Then came the Apple Silicon, which was, I think, in 2021. So we had Amperes in Google, I think, in 2018. And for us that are doing Java for some of our workloads, we were able to take those workloads that were running on a 24 core, 24 gigs of RAM, x86, and you put it on the exact same 24 core, 24 gigs of RAM, ARM64, and you were seeing a 30 to a 50% savings. Same size VM, different architecture, cheaper architecture, and it's cheaper because it uses less power. This is why we're seeing them in Raspberry Pis. So all these things are different vectors that we get to think about. So let's see if I have anything running on here. This might work. I like to use Kubernetes. Oh, there's nothing there. Well, like I was kind of ready for this. It's always fun getting heckled by your 10-year-old, right? Let's see. We're going to go to another machine, and we're just going to take a look. I have questions. If there's questions in the chat. So here's what I'm going to say right now. At my house, if you come over for dinner and you leave hungry, that's your fault. So here today, if you've got questions, ask. I don't have a story that I'm trying to tell. I'm going to listen to you, and we're going to go wherever we need to go. All right? So question.
Raspberry Pis are cheaper. Why do big cloud providers like Azure and AWS are not traditional data centers? Raspberry Pi in the last.
Okay, so Raspberry Pis are cheaper, but they're lower powered, right? So the bus that is on those can't handle the gigabits and terabits that we need for enterprise grade workloads, but there are several hosting providers, data centers that are using Raspberry Pi devices. So you're getting, again, back in the day, you'd get like a server beach or a Rackspace server for $15 a month or $30 a month or whatever it was. But now you're able to rent Raspberry Pi, bare metal Raspberry Pis for like $3 a month. So there is some change in the tide, but all of the cloud providers, well, not all, I'll say, right? Oracle uses Ampere, Google uses Ampere, AWS uses the Graviton, but Azure uses the Ampere, and I think Alibaba also uses the Ampere. Right, so, and those are all ARM64 based architectures, right? They have ARM64, so they're using less power, but then they pass that savings along to the users. And because we're using Java and bytecode, that was the promise, right? Back in 1995, right? They said, hey, write once, run anywhere. Your bytecode, the same bytecode, can go from my Mac M1 Silicon, that jar file, can go over to my Raspberry Pi that's also ARM64, but I can take that same bytecode and I can run it on an x86 with hyperthreading. That's the promise of Java, right? Once, run anywhere. That bytecode can move. And that's amazing. So the cloud providers like, hey, why aren't they doing that? There are trade-offs, right? The ARM64 architecture, one of those things is it's a single thread per core. Well, they fit the one that's at my house. It's 96 cores. Right? So tons more cores. It's not hyper-threading, right? There's different trade-offs, but with that single thread per core, there's better predictability. There's better consistency. And if you're in certain markets, like finance or other, like there's some value in that, knowing that, hey, here's how long things are going to take. So the cloud providers, the question was like, hey, why aren't they doing this? Why aren't they moving in this direction? They are, but they're doing it at cloud provider scale, at the hyperscaler scale. Good question. Did I answer it? Is that all right? Good answer? All right. Yeah, another one in the back. That's awesome. I saw one, the big block of ones that was at a conference. They were kind of doing the tour. And yeah, like there's power there and there's unique things. Does anybody remember the Beowulf clusters being popular? Like, yeah, like how cool is that? Like that I can take, and I'll also add, I had data center in my house up until I started it in college, web hosting. So Deshaun.com, I bought that in 1995. Right? So I've been doing this for a while, and I've seen things come. The data center that I had in 2008, there were 7 racks in my house. I had 3 T1 lines come into my house. But that data center is like nothing compared to the 100 Raspberry Pis that I have in my house right now. It's not as powerful as these Raspberry Pis. It's not as affordable, right? It was twice as much heat as what I have today. These Raspberry Pis are solid devices, and there are people around the globe that are using them, but there's more, right? So I'm just trying to start a conversation, trying to let you think about things. The other thing that's top of mind for me is, where are these workloads being delivered? The conversation, the session that I did at Spring IO was about Spring Boot on the edge, which ties in rightly with scale to zero. Like, we're taking more and more workloads. We're gonna leave in like 30 minutes, is that good? I'm halfway. We're deploying these workloads. My prediction, and I think there's already numbers that say this, we're gonna be deploying workloads outside of the traditional data center, outside of the cloud, more than we are into the cloud. So think of all the Java apps, all the, even the front-end apps that you're deploying today and where they're running. And I want you to, I'm gonna say 5 times more are gonna be deployed to Raspberry Pi devices, on radio towers, on rooftops. The number, actually, I might even have that. Let's do a quick pause. I try to keep everything live and available so that just in case, nope, not that one. Okay, I do got to get my act together. Just that idea that it's on the other computer. I think there's going to be 24 billion IoT devices by the end of 2024. That number sound sane? Billions. And it's just going to increase. And the idea is, like, because we're doing Java and we keep on getting new releases, right? Java's back on track with a new release every 6 months. This is why we joke in our house, you don't use Java 8, right? Java 21 was a massive improvement that came with the virtual threads, right? We've been able to do the GraalVM native images. I just couldn't do it with Spring, outside of the Spring native project that started in 2018, came to production in 2021, 2022. So we've had this kind of growth and this evolution. Thank you, Oracle and Java team. But then the Spring team said, hey, yeah, we want to be in line as well. So Spring started releasing every 6 months for Spring Boot, and every year for Spring Framework. Spring Framework being the underlying technology for all things Spring. That makes sense. We want it to have a little bit longer life, longer shelf life per version. So Spring Framework 6.2 is going to be out later this year. It's already on milestone 4. You can keep track of all of these releases here. In 2023, there was only 4 weeks in the entire year that looked like this, where there was no release. For the entire year, in 2023, there was only 4 weeks where there was not a single release of a Spring project. That's crazy. If I told you that there was 500 engineers on the Spring, if I told you there was 503 engineers on the Spring team, would you say that there's more or less? If you think it's more, give me a thumbs up. We got a couple of more. All right, it's less. If I told you there was 317 engineers on the Spring team, I think it's more. A couple of silly things. It's less. If I told you there was only 50 engineers on the Spring team, you think it's less. It's around, it's in the 50s. To think that there are millions of Spring engineers around the globe, and there are 50 core contributors to the Spring ecosystem, and they all work at Broadcom, where I work at. That's mind-blowing. That's mind-blowing to me, anyways. And a lot of times, especially I was in, yeah. No. So here, that's a good question, right? The Spring team has always been distributed, right? Wherever we can add people, we've added people. I got super lucky. Rob Wench, one of the security leads, lives in Kansas City. And I was like, well, they already have one in Kansas City. There's no way I'm going to get a job, right? Because they are so distributed. But there's a cool story that kind of relates to that. They've done a really good job of working remote, working as a distributed team. I'm a big fan of pairing, of like, hey, let's just sit down next to each other. That's where I know I can get the most done and we can have a conversation. But it's one of those trade-offs that you have to do. Well, recently around the Spring AI project, Mark and Christian, they're like, hey, we want to get this release out. So Mark flew over to see Christian and hang out. And they knocked out massive changes, massive updates to the API around Spring AI. And it just took them getting together instead of they're on opposite sides of the globe, opposite sides of the day, and doing the asynchronous where the loop, the round trip for, hey, I'd like to do this change. And then the act of that change, it just took longer, but just getting into a room allowed them to get releases out. And there's a time and a place. There's a time and a place for that. You can't just be distributed. There's time. You have to learn about the rest of your team, right? And a team is a system, an organization, and that's important. Yeah.
So I know demonstration you need with Graal. Other than that, I mean, there are so many different corporations built JVM. Amazon's got one, you got GraalVM there. What is your favorite and why should we prefer one over another?
So that's another great question. What I like to say is JVMs, JDKs are one size fits most, not one size fits all. Have you guys seen SDK Man? Yeah, SDK Man is an amazing tool. So you get a lot of these releases available to you, and you can switch. You can go between them. So I can say here, I can say, I'm going to do SDK list Java. I've got multiples. So we've got Liberica Nick, the Liberica, and then I've got the Graal JDK from Oracle Labs or from Graal Labs. Those are the ones that I use on this machine. But depending on your workload, each one of those JVMs has some kind of different things that they lean into, different reasons, depending on your workload, that you might want to change. You might want to make a change. In this scale to zero thread, the Spring team has been doing a lot of work on what we call runtime efficiency. So first there was the native image support, the AOT processing, which Quarkus had a great head start. They were doing that for a while. And now, yeah, there was value there. Yeah. I don't think that I have any stories of a JDK, yeah, other than JV8, right? But I will say this, right? My son and my daughter, like their Xboxes are in the room. So I talk with customers all over the place. And I'm always trying to get them to get on to latest and greatest. I do the demo that my son just did. I do that demo about 20 times a week. Just to like say, like, look, there's a way to upgrade. There's value in upgrading. Just by doing the upgrading, you can save money. If you don't, you're leaving money on the table. And who has money to leave on the table? And in some cases, I say, and I verified this with my lawyer, in a court of law, I might be considered an expert in the United States. And if I've explained to you that you can upgrade from Java 8 to Java 21 or Java 22, and if you upgrade from Spring Boot 2, which is out of support, up to Spring Boot 3, and you can do that in seconds, like my son showed, it was 25 seconds for the upgrade, and you do nothing, in the United States, in a court of law, that might be considered gross negligence, right? That I showed, hey, your house is on fire, and you don't do anything. There's real money, and depending on the type of organization you're in, you know, private versus public versus government, et cetera, that might be considered gross negligence. And I don't say that all the time, but it's true. But there's easy paths to go forward, and we've seen it. Open rewrite is amazing. I'm a big fan. Jonathan Schneider, the creator of the framework, he used to live right down the road, in between here in Kansas City, in Boonville. And he's also the creator of Micrometer. So the guy's brilliant, period. He created Open Rewrite. And I've been a fan ever since. And I started showing like, oh, here's how easy it is to get on the latest and greatest. I took that around the globe. And then I saw customers, they were like, oh, we want that. We want, let's scoot. We're going to go this way. We want that. What customers were doing was they were saying, hey, this is my path to production. They were taking and they were trying to build some machinery that would look at their repository. And on that path to production, they had three options. There's three different ways of leveraging open rewrite that I saw in the wild. The first one is like, hey, stop. Like, you're not, I ran the recipe to get you on the latest and greatest, to get you on 3.3, and I saw a git diff. And because there's a diff, that means you didn't run the recipe, you're not on the latest, so you can't go to production. And at the beginning, right, back when I started using this, I was like, oh, that makes sense. Put it on the developers, shift everything left. That made sense to me. The second one was like, don't worry, I have the recipe. You're on Spring Boot 3.2.6. I'm going to upgrade you to Spring Boot 3.3. So it was, don't worry. I'll say the platform team, will take care of it. Make sense? Like, hey, yeah, it doesn't matter. So as a developer, you don't have to worry. You've got an upgrade path. There's a recipe that'll keep you on the latest and greatest, keep you with all of that latest and greatest performance, security. And how many people have heard of Josh Long? Josh Long, if you're in the Spring ecosystem, you've heard him. He's on my team. And what happens, he goes out and he shows you all the cool stuff that you can do. And he shows it in a blink of an eye because he has it all in his head. And then you're like, oh, well, I've got to be on Spring Boot 3.3 to do all those things. And then that's the sweet part. He's like, he shows you all the cool stuff. And then you go back to your laptop and you're like, oh, I'm on 2.6. Oh, and we're still using Java 8. And that's the sour part. So we call it sweet and sour. Josh is sweet. And then you get that sour taste in your mouth. That's when you call me. So I follow Josh around all over the globe and I'm showing like, hey, open rewrite's a thing. And I've been doing that now for over a year and a half. That same thing, the last piece, the last thing that I saw as companies were trying to do this upgrade journey is they were saying, hey, we don't have, Netflix is very public about this. Paul Baker has been on several streams where the Netflix journey from 8 to 11, they got a 20% performance boost. Netflix is a streaming company. You might have heard of them. They do like videos online that you can go and watch instant, and they're all over the globe. And at their scale, I heard one time that they're like 30% of the internet traffic around the globe. Right? What is that? How much of the internet traffic is due to Netflix? So these 20% performance improvements, according to various sources, 14.50, still, of global internet traffic, 15% is from one company? So now answer me this, if they could save 20% on that bill of how much does it cost to run the global internet? I mean, at least, right? And so now think at their scale, when they went from 8 to 11, they got a 20% performance boost. And then from 11 to 17, they got another 20% performance boost. And this is reported, even if it's, we can say 10, we'll be conservative, say 10. When they went to 21, another performance boost. At that point, it becomes a big deal. It becomes a differentiator. If your company could squeeze out that 10 or 20% performance boost and stay on the latest and greatest, and your competitors can't, if they haven't figured out how to do that automation, then that becomes a differentiator. That might be the thing that helps your company survive. Your RSUs are going to be worth something someday, your options. The last thing, and this is what I got from Netflix, Paul Baker, that platform team, they don't have the ability to say, stop, you can't go. There's a responsibility. That culture of responsibility at Netflix says, I can't do anything. The only thing that I can do as a platform person is say, here is a PR. pull request. I'll say pull request. Please merge it. That's all they can do. So they can have all the recipes that say, hey, here's how you upgrade from JUnit 4 to JUnit 5. Here's all the recipes that will upgrade your Java 8 code to Java 11, that JavaOx to Jakarta. It'll do all those things. Here's the PR where I've done it for you. Please merge it. This is going to save us a lot of money. And the way that they did this at scale, I watched and I saw, and I would ask in groups like this, I would say, hey, take that open rewrite, the demo that my son showed. Is she doing sign language down here? That's awesome. This one, it has the cheat code. Like you can go and just copy this bit right here. That's the one that my son ran. On any of your Maven projects, there's a similar one for Gradle, but you can run that on your code. It'll do the upgrades, dependencies. It won't do everything, but it'll handle your Spring bits, most of them, and then run your tests. And if your tests pass, take it to production. So over the years, I was doing this, and at the low end, I was seeing, at the low end, 15%. So I'm saying 15% of your workloads, this is interactions that I had, customers that I have around the globe. The lowest number was 15% of the things that that team was taking to production were able to upgrade automatically with Open Rewrite or Spring Boot Migrator. At the high end, it was 70%. They just hadn't taken, they didn't know about Open Rewrite. They didn't know about the other ways that we can upgrade safely. And they didn't realize how much money they could save. But after a conversation just like this, they went home, they tried it, they had the cheat code in hand, and 70% of their apps got upgraded automatically within seconds. Tests are passing, we're in production. Somebody got cookies. I know, I say that, Joe, because some team did get cookies after they did that. So it's funny because it's true. So this is where we are. The native images, that next step, if you can get up to Java 17 and Spring Boot 3, then you have the ability to do the native images. For some of your workloads, maybe not all, some of your workloads are going to have a smaller footprint. They're actually going to perform better as a native image. So you have these options. You know, so I'm getting excited. One of the other runtime efficiencies that we got. So Open Rewrite is cool. I'm talking about native images. The next really cool thing that came along was Project CRaC. How many people have heard of Project CRaC? Oh, it is coordinated restore at checkpoint. Anybody heard of this? Yep. Oh boy. This idea, the native image footprint we saw, hey, it was 84 megabytes, right? But the JVM is still super powerful, super amazing. So some workloads are still going to get a ton of benefit out of the JVM. It depends. You've got to do a little bit of exercise. I can't give you all the answers. Everybody's like, oh, which one should I use? You have to do a little bit of the work. What this did, instead of saying, hey, we're going to take that hit and compile to native images, what it does, if you know, like your workloads, they kind of like spike up at the beginning and then, oh, we figured it out, and they kind of level off at some later point, right? They do all the class loading. But sometimes that startup, that was a complaint about Java and the JVM. It is slow. And this is a complaint, especially if you're doing serverless and you're paying per millisecond, right? That function that's gonna, take it out of this database and put it into that one. It took a minute or a second and a half to start up, and it took 15 milliseconds to actually do the work. And that math didn't add up. The math wasn't mapping. So Project CRaC, coordinated restore at checkpoint, said, hey, what if we did it a different way? Like, this is my line over T. They said, hey, what if I could take a checkpoint after we've done all the things, after we've warmed up, connected to all the databases, had my classes are all loaded, after I've warmed up, what if I could take a checkpoint there and I could write all of that down to disk in a snapshot? or a checkpoint. This is slick. Let's see if I can get this to work. I'm on Tanzu. And let's go here. Fun, Deshaun. No, project. I might have a demo here that we can do. Hello. AL. I'm just going to do the restore. So I've already taken a checkpoint in this example. I've already taken a checkpoint. There are some caveats, just like in the native image, bytecode is not going to travel everywhere. The native image, wherever I build it, it's going to work on that operating system and that architecture. So if I build it on my M1, which is a Arch64, if I'm using a build pack that has Linux, sweet, I can run and I can deliver that OCI image anywhere for ARM64. Here, same thing. This one has a little bit finer grained. What we're finding is even if I'm on x86 architecture, but I switch from the Thunderbolt to Ice Lake processor, sometimes it doesn't translate. Sometimes I need to have that image specific for that CPU as well. And this technology only works on Linux. It's using part of the Linux kernel as its driver for this capability. So there are some trade-offs here. But we're going to go here and we're going to restore it. So we already did the checkpoint. Spring adds in those hooks so that you can say, I would like that checkpoint taken here. And it will do it automatically, create that checkpoint image for you on disk. Oh, I don't have Docker running. So I will, what I call dance while that comes up. This is the cool thing. Sometimes when I do this demo, the Project CRaC startup time is even faster than the native image because all the things are connected. It's already done. So it doesn't have to do it. So you don't even see like the startup time. You don't even see that step. The logs are already passed. The Spring Boot logo is already passed. And it picks it up right from that spot. And it moves. So now that we've got that up and running, let's try that again. Oh, it's pulling it down. So I didn't have the image locally, but we'll see. We'll see how long it takes to start up. And hopefully it works. But that's the second thing. Yeah, question.
The build packs that you mentioned, build is under him for you, or is it like shift us?
So I did something here. Does it match the detect? Oh, so he generated his image. Let's see if I can do this. We'll create it. The question was about build packs. Like what do build packs do? Build packs, you can think of them as OCI images, like they're like a Docker image, but they're using a different framework. They have a different model. Cloud native build packs is the thing that I get excited about. That's what I've built. Not only the one for ARM64 native images, but also COBOL. Has anybody heard of COBOL? Cloud native COBOL. Do you remember back in the time we talked about it a little bit ago? Cloud native COBOL.com, New Jersey during the pandemic, they're like, we can't send out our checks, the stimulus. We can't help people that need food because we don't have any COBOL developers. Cloud native build packs was a framework that had been introduced. I think it was in 2018. It was a collaboration between Pivotal and Heroku. Heroku, cool platform, right? Cloud Foundry, another cool platform. And they were like, hey, we both get this build pack idea and we love it. Let's work together. And that's where the build packs, cloud native build packs were born. So think of it like a Docker image, but it's upstream. And what it spits out is a Docker image, an OCI image. So not a, yes, you get a Docker image. And with Spring, I get it super easily. So this, I think the checkpoint is good. So now maybe we'll try that restore. And this is just to show how fast the Project CRaC startup is, hopefully. 57 milliseconds. Do you remember how fast yours was? It was 111 milliseconds. So this Project CRaC example started up in 57 milliseconds. That's pretty slick. The other cool piece here is, let's go, I'm thinking, let's go build a new one. Let's go back to start.spring.io. We had a project here, yes? I brought my kids. This is the cool thing, right? This is one of the benefits of my job is I get to take my kids. So we're gonna go here and we're gonna start a new project and I'm gonna show you the build packs because it's cool. I'm gonna close this. I don't need anything. I need an actuator. I'm gonna add one more. I'm gonna add the web because then I get something that will start up and run and I will have a health endpoint. So I don't have to write any code. I can just go. So let's generate that. I have the Graal native support. This is all that I need. I'm gonna switch to 21 because my build pack that I have is only gonna use 21 and I'm gonna generate a demo. And we're gonna go here. And we're gonna unzip demo, hello.zip. And this is the benefit. This is one of the benefits. Instead of having to write a Docker file, I get mvnw, spring boot build image, and this is using that cloud native build pack. So all of the rules, all of the things that I need in order to generate an OCI image, I get from that Maven plugin. So this version of it is going to build a OCI image. It's pulling down the build pack, pulling down all the rules. And you can imagine what that's going to look like. I'm going to have a layer, just like a typical Docker file. You're going to have a layer that has your app. And then you're going to have a layer that has your JVM, your runtime, whatever that would be, right? In this case, it's Java. And you'll have a layer, that one's probably going to be a little bit bigger, that has your operating system. That makes a lot of sense, right? This is what your Docker image looks like. And with Docker files, like I said, if there is a bug in that OS layer with a Docker file, you've got to go rebuild the whole thing. The Docker file format is, hey, from this base image, add these things. And you get a layer for each one of the lines in that Docker file. Cloud native build packs said, okay, cloud native build packs in the spec said that operating system exists in a well-defined place on that disk image. The runtime exists in a well-defined place on that image. They will not overlap. So what you get with a cloud native build pack is I have the ability to replace the JVM. I can have a running image. If there's a CVE that came out right now and it's critical, it's high, I can go in production because I've got millions of workloads. I can go and patch the JVM layer or the OS layer because it's cloud native build packs. And that was defined in the specification. That's something that you can do. If you don't have that and you're doing Docker files, you have to kick off those millions of pipelines. And you have to cross your fingers and pray that somebody's not exposing you in that time, because that time is important these days, right? That time is a big differentiator. It wasn't that long ago where we would say, yeah, we're patching. We had Patch Tuesdays for Windows, right? That was great, wasn't it? Good times. And there was times when companies were like, oh yeah, we patch all of our systems every 90 days. All of our systems we patch every 90 days. And I'm telling stories because I worked with companies and they had infrastructure, they had VMware's vSphere and vMotion, and believe it or not, we found a virtual machine that had an uptime of 10 years. That's way too many. That's older than you, right? An uptime of 10 years. How much rot, how many bad actors are sitting on that VM that had just been vMotion, they didn't know who owned it, they didn't want to shut it off because who knows? But that was the same company that says, oh yeah, we patch all of our systems every 90 days, right? So there's risk, that delta, that time, the speed at which we're doing things, that matters. Build packs, one way of improving that, but I also talked about the native image. So with the Project CRaC example, that native image, that registry, that OCI image, it has to have a JVM. It has to be on Linux, but it also has to have that checkpoint. So there's another little layer in here for that Project CRaC that has that checkpoint to start up from. But everything else is good, right? You still have all the benefits of dynamic class loading, all the other benefits you get from the JVM, you can still do with Project CRaC. Now, on the other side, the native image approach, it looks like this. There is no runtime layer. The native image that we built is optimized for that architecture, that operating system. So the containers, again, if we're doing millions of these containers, the size of those containers adds up. I don't know if you've seen like an ingress bill for an enterprise at AWS, right? Just the traffic, just the registries makes a big difference. And we're using build packs because of the build pack specification. When I make a change to that app layer, and you get some of this benefit with Docker files, but just not at the same scale. The only thing I'm transferring to my registry is that app layer. Everything else stays the same, but I get upstream support. Paketo is where I like to play. They have these build packs for, Paketo.io. They have build packs for multiple languages. GraalVMs, which that's the native image, Java, Go, .NET, Nginx, Node, PHP. I laugh when I say PHP. Ruby and Python. Like you have this concept, and the idea that got me excited was I could have a polyglot organization. Not my favorite approach, but I could. And I could have everybody go into production with all the best practices all the time. My path to production was built with build packs. The Raspberry Pis that I have at my house, I open it up, and we can go and see that real quick. I have now, I ran it, I've got that native image running, the OCI image. I didn't have to do anything. There's no Docker file, there's no magic. I got a OCI image that I can run anywhere. That's pretty slick. But now I can take those, I'm gonna go back to Juice. I'm going back home, going to the home lab, and I'm gonna jump on this box, maybe K9s. And I open up my home lab. I open up my infrastructure to people around the globe, trying to teach them Spring Boot and trying to teach them the values of scaling to zero. So I have a bunch of Raspberry Pis, I have a bunch of infrastructure, but I'm letting other people run their code on my infrastructure. So in this case, it's Eunice. Eunice, she had a job, she had to go and create something. It has to be public, right? It has to be a public repository, and it has to follow some conventions. GitHub.com/EUNICEE-org. So here's her Spring Cloud Gateway, her project. This was step one. Everything that comes into my infrastructure has to go through Spring Cloud Gateway. This is what you have to do. I'm building the image because it's running on my infrastructure. Do you want somebody, especially if it's your house and your kids, do you want somebody delivering a Docker file and say, hey, run this for me? How would that make you feel? Hey, yeah, don't worry about it. It's Spring Boot, and here's the Docker file. Your platform teams think that same way. Your CISO is restful, not sleeping, not restful, sleepless, because the number of Docker files and who knows what is in those Docker files. And lots of companies have that golden image. Like, no, this is the one. Like, we've hardened this one. Just use this one. And then what? And then tomorrow when you wake up, there's a new CVE. And then, oh, we updated the golden image. Now everybody go and update your pipelines. This is painful. And I say this because I have that scar tissue, and this is what we're doing. But we're here to talk about scaling to zero. Eunice has her thing that we're not going to see it. Wait, she has a gateway service deployment. Wait, I didn't want to see that. I wanted to see like a zero scaled nothing. It shouldn't be there. But if we go to unisb.org, which that's okay, there's not anything there. We're going to go and actuator health. She's running this application on my infrastructure. I'm going to do this because I want to see it. It's scaled up. It's running on Raspberry Pi infrastructure, but I want to see that the seconds, it's only up for seconds. Sorry, I got to do this tight screen. I just want to show you the numbers. Age. There should be one that's only up for a few seconds in the unisb org. And I don't see it, so maybe it was already up. So we're going to do a different one. We're going to do Java Grunt. I am Java Grunt, right? But it's the same thing, javagrunt.com. So this, you'll see a little delay. It's hitting my Raspberry Pi. My Raspberry Pi saying, oh, here's that traffic. Here's that data. I do need to update it. And that one here, 9 seconds. It was scaled to 0. So you can imagine on this infrastructure, I could have hundreds of these applications running. This one is, in fact, a native image. We can go take a look at the logs and we can see like, hey, can I get that to fit in now? Maybe we'll see it. Started up in 0.274 seconds. Like, that's cool. But the thing is, on that one device, on that one Kubernetes cluster, I can have hundreds of these apps. When they're not being used, they're not being used. They're scaled to 0. And when I need them, I can call them. You know, whether it's this one or others, I can call them. And that's the thing that I want to hit home. Let's hide this thing. Oh, sorry, my Zoom is interfering. But all of these applications that exist there are doing the same thing. YouTube, listen, or when I do a YouTube stream, YouTube says, hey, I want to send you this information about your stream. And again, it takes a second for it to load, but it's doing the native image, it's standing it up. Why didn't it? I didn't do the slash. I needed the ending slash. So here I'm using my documentation at the root of that project. Test-driven documentation is the other TDD. My documentation gets delivered as a part of my test, as a result of my tests. And that's how we go to production. But wait, there's more. I talked about AOT processing those native images that I'm running on my Raspberry Pis. There's another benefit here. We talked about Project CRaC and like, hey, maybe the native image isn't the right way to go. Maybe I want all the benefits of the JVM and I'm willing to make that adjustment. Again, it depends on your workload. But recently we got another massive improvement and it's called CDS. This is something that has been in the JVM for a long time, but the Spring team has made it so that we can adopt it with the flip of an argument. Hey, I would like to use the class data sharing. Class data sharing. And what this is doing is it's exploding the jars, it's putting the things in the right place, and it does a run. It does a test run. And it says, this is the way our classes should be loaded when it builds the image. So it's not native image speed. It's not Project CRaC speed, but there's nothing else that's required. Project CRaC is only supported by 2 JVMs today that I know of. Azul, their Zulu JVM, which they created the format, the first pass of Project CRaC, and then Liberica also supports Project CRaC. Those are the only 2. With class data sharing, I can get almost that level of startup without having to do anything else. It's an argument that I passed the JVM that says, hey, I want to use this class data sharing support. And Spring Boot now supports that. So I can get that sub-second startup with a regular JVM by adding a flag, and that support is included in Spring Boot 3.3. And that's amazing. So that's what I have. This is the cool stuff. This is where we're at. I'm going to go back to this demo here. The native image stuff, that's included. I can do a native image. Logan showed how to do the native image binary, but I can also build that into a build pack. I can say, hey, I want that native image, and this is what I do. -p native, and then I use the same command, -spring boot build image. Because I'm on ARM64, I have to use a different build pack. That's okay, this is the same process. Now that you've heard about native images, this is your next step. On your path to production, build just like you normally do. But I'm going to ask that you say, hey, I want to have the rest of the team's apps on my laptop. I might want to use Kubernetes or Cloud Foundry locally. I want to have those things. I cared about having all of the apps, but I never had a situation where I could run for Garmin Connect, for example. I couldn't run all of the 118 different microservices on my laptop. Nobody could until now. What I'm going to say is, this is what I want you to think about. I want you to start building on a separate path I want you to start building the native images for ARM64 and for x86. What this is going to do, it's going to allow you to deliver a native image to your friend and have it on your laptop. You can have these things scaled to 0, so you still get all the benefit. You can still run your IDE and Slack on your laptop. And when it's time to go and start up an application, it'll start up in 0.24 something seconds. And you can validate, and you can start to work with the rest of the environment. Over the years, we've come up with a lot of different tips and tricks for how we can make it look like we're connecting to that other service. But today, I can have hundreds of these services from my org deployed, scaled 0 on my, this is a 32 gig laptop. And I can still do my work. And with the benefits of test containers, I can have all the backing services that I need. And the power of Spring and the bindings. I can have the confidence that that image is going to work on my laptop just like it does in production, whether it's on Cloud Foundry or Kubernetes. This is where we are today. So maybe you heard, maybe you haven't. Broadcom acquired VMware back in November. And for the Spring ecosystem, a lot of people are like, hey, like, what does that mean? Right? They got rid of a bunch of SKUs and they made a lot of changes. But what does that mean for Spring? I love Spring. It's been around for 20 years and it's helped me out. What's going to happen to Spring? And I want to address that. Since the acquisition, we've had 2 releases, right? Spring Boot continues to release every 6 months. The Spring framework, I'm going to go back to the calendar. Spring framework is on milestone 4. Spring framework 6.2. There's milestone 2. Wait, that's last month, right? Oh, 6.2. Milestone 4 was supposed to come out today. We'll see if it comes out. But I want to make sure, in case you're wondering, Spring is still moving forward. We're still planning releases for November and beyond. The Spring team is still working closely with the Java ecosystem in order to keep up and help guide where these things are going. So I'll pause. I'll pause there and I'll ask for any kind of questions that you have. Again, come to my house for dinner, you leave hungry, that's your fault, okay? If you're here or you're online and you've got questions, ask. I don't want you to leave hungry. Thank you. Yeah. Question in the back. Yep. Yeah, so I started doing the native image. Like the question is like, hey, is there more coming? Like, are we getting closer? Sebastian has really great, he's done a lot of the work on the native image and CRaC and all the other CDS stuff. Like he's in deep with the JVM and with the Java team and the Java ecosystem looking ahead. And he's got really pretty pictures. Like you have these knobs that you can turn to improve the startup time. If that startup time, those milliseconds are the things that's important. The AOT processing alone. AOT processing that came out with Spring Boot 3, Spring Framework 6, said, hey, everywhere you have a proxy, everywhere we're using a reflection, let's go ahead and implement ahead of time. Let's put those things in place so you're not doing the reflection things at startup time so you get a faster startup. And then we added that with the GraalVM. So the GraalVM didn't have to have a bunch of hints. And you didn't have to add a bunch of code to tell GraalVM where to go find the reflection. That's one of the things you need to do with GraalVM. It doesn't know where everything is. So that was the first kind of iteration. Project CRaC came along. The one caveat with Project CRaC is Linux, the CPU thing. You might have the same size VM in one region and the next, but the CPUs might be different and you might run into problems. The other piece is with that snapshot from Project CRaC, all of the things that were in heap, those are all written to disk, including your credentials. So you have to have a mechanism to protect that, which when the trade-off is I get, massive startup time and all the benefits and performance of JVM, right? There's lots of companies that are doing that. And there's going to be improvements coming from there. The last one was class data sharing. This is just another attribute, another flag that we're passing to the JVM, to our build pack. It says, hey, I want you to take a little bit extra time at build time to give me a little bit faster startup time. And this is all, I think, under the umbrella of Project Layden, which massive stuff. It's been going on for years, but we're getting kind of these knobs where we can say, hey, I'd like more optimized memory footprint, like a native image, or I want more optimized startup time. I'm not really worried about the memory. You have these things that you can fine tune. That's the idea behind Project Layden. And of course, the JVM is coming out with new versions every 6 months. The team at Oracle is continuing, and they're looking years ahead. They are looking years ahead. There is so much more to come, right? And I think we're just getting started with these optimizations. The coolest thing right now is there is not a language out there that can say that they've got something better, right? All of the best things that have happened that other languages have had for the years, they are all showing up in the JVM today. And now, even the startup time, they don't have, there are no other languages that now have something that they can hold over, Java's head. All of those things are being replaced. And we haven't even talked about the improvements in the language itself. So yeah, I expect that there's a lot more coming. Yeah. Yep. Nettie. Yep. 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 Yeah. Yes. Yep. So that is Dr. Dave Sire, one of the core, one of the people that is a part of the Spring team that doesn't need to be a part of the Spring team. We are just lucky and blessed to have him. One of the many, right? There's a lot of people that are on the Spring team. They don't need a job. They're here. We're lucky that they're here. But back when Quarkus hit the market, they're saying, oh yeah, Spring takes too long. He kind of took offense. So he went and showed like, yeah, we are doing a lot of things that make it easy so you don't have to do a lot of work up front. But we were also still supporting Java 8. We've been supporting the workloads that we started with 20 years ago, right? We still had support. At Spring 1 last year, Dr. Sire and Josh, they went through a Spring Framework 1 app with the old XML, if you've been around, and they, on stage, they upgraded that app from Spring 1 to 2, 2 to 3, 3 to 4, to a Spring Boot app. Now it's containerized, and now it was at Spring Boot 3.1 that day. And they did it all on stage within their, whatever, 15-minute presentation. And there's massive improvements that have come along. And all of those improvements, all those benefits landed in Spring Framework 6 and Spring Boot 3. Now, again, a week and a half ago, I got to see Jürgen, co-founder of Spring. I got to see him on stage talking about the bean initialization and the changing in the algorithms that are coming in Spring Framework 6.2. This is a startup time thing. And the thing that he said was, there are companies that have thousands of beans loading in their WAR file or their EAR file, thousands of them on these Spring projects across the board. And they were running into problems of that initialization. It was taking too long to start up. So scale or not, they weren't getting it. And to see him on stage, he talked for a whole hour about the new algorithms for bean initialization for an entire hour, and he got excited. So he's my people. We can sit and talk about it for lunch. But that's what he did. There is a new initialization algorithm. There are tickets that have been open for years that are now closed, and they're going to be delivered with Spring Framework 6.2. And at that time, I was like, I don't think I've ever delivered something that had even hundreds of beans. And then it was this week, not one, but two customers, I was like, oh, this is one of the customers that's been waiting on this feature for years. That's another big thing around Spring Boot 3.3 and Spring Framework 6.2. Across the board, the projects, and if you didn't know, spring.io/projects. All of these projects, that's not even the best picture. Let's go here to the support. These are the things that the Spring team is working on, right? There's projects that have come and gone. Each one of those projects has kind of a life cycle. Some of them have longer life cycles, some of them have short, but each project has its own life cycle. And across the board, these projects all, they made a massive effort to go in and look at the backlog. And there are hundreds of issues that have been open for years that are now available. They've been fixed. And that's amazing, right? I remember the day I was falling in love with Spring Boot. GitHub.com/spring. Is it projects? Spring Boot. I was using it, and this is in the 1.0 timeframe, and I came over, and there was over 100 issues, and I was like, first of all, I didn't want to air my dirty laundry. I was using Spring Boot unauthorized in my company, and I didn't want to expose myself. But then, additionally, that there was that many issues. I was like, they're never going to get to my issue in time, so I didn't open an issue. And now somebody that opened an issue, probably in that same time frame, now they're getting it fixed. How cool is that? Just for free, they didn't have to ask anything, it's just there. That's pretty exciting. And I think there's a lot of that, not just with Spring, but with just Java in general. We're getting these massive improvements, like virtual threads, which I'm a fan of. A good question. Hopefully that answered. You're right on the boat. And yep, things are heading in the right direction. Things are heading in the right direction. And that startup time has massively improved for Spring projects. Oh, and I wanted to say, as you were starting, these old middleware-based applications. This is a Spring Boot migrator. This is an experimental project. It's similar to Open Rewrite, but it has these recipes. And this demo I delivered to a company here in St. Louis, migrating an application that's running JEE, EJBs, JAX-RS, SOAP, JMS, all these things running on a WebLogic middleware. So of course, it was stuck on Java 8. And they were coming up for renewal. And of course, well, the renewal, you're a big company. You're a Fortune 500 company. Yes. And they called us and they're like, hey, how long would it take to migrate all of this stuff that's been running our company for 20 years? Is it possible that we could migrate off? Even if everything started with Java 8, right? Java 8 was 2014, right? That's still 10 years ago. Been running. They're like, hey, could we possibly do it? And this demo, I'd be happy to show you, takes that EAR file that's running on WebLogic, runs some recipes, and it converts it. The tests we run against WebLogic, we run them against a containerized Spring Boot application, and all the tests pass. This is where we are in 2024. This is pretty slick. So this is the thing that I do. I yell, I scream. I am convinced that you should be on the latest and greatest version of Java, of Spring Boot. We've been doing it with Linux and our phones. We don't hesitate to update an app on our phone, right? It's been figured out. I don't hesitate to pull down the latest Ubuntu releases on my application or on my laptop. I do brew update. right? Brew upgrade. I do it twice a day, every day. And I just take it. And if I run into a problem, occasionally there's a problem, but I would rather run into that problem occasionally and have the muscle that I can upgrade, because when I need it, I know how to do it. So all the Raspberry Pis that are in my infrastructure that are running these things that are, instant startup, scale to 0, on all of those devices, I run sudo apt update, sudo apt upgrade, -y, boom, go, and I reboot it every day. Because if a bad actor is on one of those devices, sitting and waiting for stuff, I'm patching it every day and I'm rebooting it every day. So good luck. Because I'm letting people ride my platform that I've never met, like Eunice. I'm bringing workloads in, so I've got to cover my butt the best way that I know how. And one of those is repaving my infrastructure so that if a bad actor lands somewhere on my infrastructure, they've got 24 hours to figure out something. And that bad actor, that persistent threat actor, that's the ones that have been making the news the past 5 years, right? They were sitting inside of, big corp, sitting on the network, sitting on a VM that's been uptime for 10 years, and they were just listening for network traffic, listening for something interesting, not raising any flags, just sitting and listening. And that's how they ended up putting a company on the front page of the news for the wrong reason. And I just don't want to fall for that. Any other questions? This is fun. Yes. Question in the chat. Help me out. What was the question in the chat?
Okay, how can Spring Boot's auto configuration mechanisms be leveraged or extended to achieve optimal performance for highly specialized use cases that deviate from standard application patterns?
Ooh, that's an interesting question. Like, how do I optimize? So I'm going to say this. The experiment. The question is like, hey, how do I make my special non-standard JVM Spring Boot application? How do I make that more performant? How do I get the benefits? The things that I would try today, the workloads that I was taking to production, they all weren't the same pattern. Some had tons of writes, some had tons of reads, some needed cache, some didn't. So I leveraged the JVM. Sometimes I gave them larger heaps on purpose because I expected different workloads at different times of the day. So things that I didn't have to deal with the Spring auto configuration. It had to do with the actual workload. Because no matter how my application is written and delivered to production, that doesn't say anything about how it will perform with the workloads that are going to be ran with it. Right? So you have to get into your performance. Like, how does it perform against my production workloads? And how do I optimize for that? Well, I got to give it production workloads, and I experiment with different JVMs, like we already mentioned, but also garbage collectors, right? We've got a plethora of garbage collectors, and these tiny switches, which can just be a configuration change, can take that same application. You can deliver those flags to your build pack and deliver a containerized workload that's optimized for that use case. You have those benefits. That's the approach that I would take. The auto configuration, trying to figure it out from the code. I don't know that that's the best approach. There might be a way for some use cases that you can figure that out, but I think the only way to truly optimize for your unique workload, whether it's a common pattern or not, is to do the test, do the experiment, and validate it. But the sysadmin that I had for the workload that I'm reminiscing about, for me, this is therapy. I'm just gonna vent a little bit. The sysadmin said, no, I read this blog that said, this is the best garbage collector to use. So that's what we're gonna use in production. And I was like, I didn't even know what to say. How could I argue? He read a blog. Except I have a bunch of tests where I've surrounded myself with people, and I myself have made my career out of career limiting decisions, and this was one of them. I deployed completely unauthorized. I deployed self-service VMs, and I ran those experiments, and I ran those tests with production workloads, with the different JVMs and the different garbage collectors, and I had the data to prove it. I had the data that backed the decision to why I wanted this different garbage collector for this specific service. JVMs, garbage collectors are one size fits most, not one size fits all. Any other questions on the chat? All right, let's hear it.
What are the potential future directions for Spring Boot and the broader Spring ecosystem, considering the evolving landscape of cloud computing, containerization, and reactive programming paradigms?
Yep.
I want to prepare for what's next.
Yeah, here's what I can say. Because Spring and Java, I'm going to put them both in the same bucket. Because they are evolving so fast and they're keeping up with the new speed of business, they are going to be prepared for what's ever next. I know I spoke with the Oracle team last year, and they were already looking at AI and the things that need to change inside of the JVM and the Java language to support AI in the future, right? Those are the PhDs that are working on things. We already have this new kind of paradigm, data-driven features inside of the Java language, and it's just going to continue. So where is it heading right now? AI. I don't know if you guys heard about AI. AI's popular. Spring has a project group called Spring Data. And for me in my career, Spring Data allowed me to, on one day I'm working against an Oracle database, and the next day I'm working against a MySQL database or a Postgres database or a Redis database or a Neo4j database. But because I had Spring Data, I had the abstraction layer, and I could talk to these different backends with relative ease. I wasn't really concerned with whether Oracle was going to work or Postgres was going to be the better one. I didn't need to have that concern. I was getting my features out. Spring AI gives me kind of that same abstraction layer over a lot of the popular LLM models that are available. OpenAI and Bedrock and Gemini, Ollama and Hugging Face. You have all these things. And it is, right now, it's the hottest project in Spring. It has the most contributors. It has the most contributions per day. It is hot, like super hot, like don't touch. But it runs on Raspberry Pis. So if I'm preparing for what's next, I'm definitely trying to get my handle on AI, and I would definitely lean to Spring AI as an abstraction layer so you can find out for yourself which one of these models is going to help me in my workloads. And then I'll remind you that the S in AI stands for security. You might not want to send all of your AI workloads up to the cloud. I don't know if you heard about Samsung. This is the OpenAI use case where you can say, hey, what happened in the Samsung meeting on this day? And all of the notes were there, right? So remember that. Like, I'm a big fan. I run these publicly available models, but I run them in my house, in my data center. I'm not trying to send a lot of these questions, a lot of these contexts up to OpenAI or Gen. I'm sure they mean well, but right now I'm just not prepared or comfortable with using their models and their infrastructure for some of the things that I'm interested in doing. I showed you my YouTube listener. So this is my example use case. I will just hop on a stream and I'll have a conversation just like this, and I'll be tippity-tapping away. And at the end, I didn't plan it, I didn't do any marketing on it, but some of you joined and you said, hey, and we have a conversation. But at the end of that stream, YouTube sends my infrastructure, it sends a message, hey, the video's done. Here's the URL. And then my infrastructure, my Raspberry Pis, they go grab that, they download it, and then they transcribe it using free available models. So now I have the transcription from the stream that I just did. And I can put the chat in there. I can do all sorts of interesting things. But from that, I can say, hey, Llama 2, give me a summary of that stream. And then take that summary and slap it on the YouTube video. I could also say, hey, what's one of the ones that does images? Dolly. Yeah, Dolly. generate a thumbnail for this summary for my YouTube video and upload it. But I can keep all of that information. I'd like to keep that. I don't want to send all that everywhere. But now the next thing I can do is I can start to use that data and I can do RAG. I can say, hey, have I ever talked about this? Which episode did we talk about Raspberry Pis? And I can ingest that. I can use the prompt stuffing and I can say, hey, I can ask the same Llama 2 model, but I can take data from a vector database that has my transcriptions in it. And I can have that chat model tell me, yeah, you talked about it in the last 15 episodes. And here's the hot topics. These are some of those interesting things that we can do. And Spring AI makes it really, really easy. I can even ask the same question to 5 different models that are running on 5 different Raspberry Pis. I can see which one responds fastest. Like, I don't care. I just want an answer. So I send the question to 5 different models, and whichever one comes back first, that's one I send. That's one I use. Or I can compare. Different models have different characteristics. I can compare which model is answering the right way for this use case. But yeah, if you're trying to prepare for what's next, I think getting your head wrapped around AI and how you're going to leverage it, I think that's a good place to start. I compare what people are doing with AI right now to what people were doing with spreadsheets in 1980. Right, when we first had that personal computer, we have, oh, look at this, I can do sum. Right? It was really simple back then, right? But we were just scratching the surface, but that's the way I look at AI, and that's what I think is going to happen. You're going to have this menu of models that are going to deliver specific things for you. You're going to be able to inject your own context, your retrieval augmented generation. You're going to be able to inject that into a cell that's using this model and get your results. That's the way my head's wrapped around AI at the moment. And we can do that with the latest version of Spring AI, the first milestone. It's got those, they call it advisors. Every platform has their own kind of language for how you can send it. I can give it a context. I can say, hey, if there's a question about jugs in the Midwest, I want you to use this data set. This is where we're at. So that's my answer to where should I lean into? Where's it going? It's already containerized. It's Kubernetes native. It's cloud native. Spring works. But AI is kind of that next step if you're looking for which way to go. Anything else, Bruce? Anything else? Are we going to do a raffle? Or then I'm going to pause. I'm going to thank you so much for your time.
Okay,
Let's
so
get on with that raffle.
thank you for a great presentation here,
I
Deshaun.
need to screen share anything?
Okay, no, don't change anything
Right.
here. So, yeah, what we need to do here is we need to turn off the recording. But for those of you who are online, stay online if you would like to participate in the raffle.